Hi folks, today I bring you a panel from a Sony MiniDisk deck, model MDSJE530. This panel uses a VFD display controlled by an OKI driver, reference M9201. Even though we have already covered other OKI drivers on the channel, there are always differences between models, and this one is no exception. Even so, most of the concepts discussed here can always be applied to other panels that use similar drivers. One interesting feature of the M9201 is that it provides 4 GPIO pins. On this particular panel, one of those pins is used to control a red LED, which you can see operating during the animation sequence. The driver supports up to 24 grids, even though the pins are identified as COM lines. In this display, all 24 grids are actually used. Because the grid and segment voltage can reach as much as minus 60 volts DC, the phosphor can produce a very intense brightness level. For our tests, we used minus 29 volts DC, which already produced excellent results. Since we had previously developed code for the M9202, we decided to reuse part of that code as a starting point. Of course, special attention had to be given to the differences between the two drivers. Even so, we encountered an unexpected problem during the implementation. The issue appeared in the infrared control section. The infrared receiver installed on the panel did not match the component indicated in the service manual. My suspicion is that this was the result of a previous repair carried out on the original equipment. According to the documentation, we expected to find a TSOP3238 receiver. However, the component actually installed was a TSOP3438. After replacing it with the correct receiver, the infrared functions worked perfectly. For testing, we used the SONY remote control. However, the code can easily be adapted to another remote model or even another manufacturer. To do that, simply observe the values received by the Arduino and displayed in the serial monitor. Then update the code accordingly. One of the most interesting features of this family of drivers is that they can work directly with ASCII characters. This makes data transmission much simpler because we can send characters directly instead of manually defining segment patterns. There is, however, a small detail on this specific panel that deserves special attention. It relates to the way the grids are numbered. The display contains 2 lines of text, each using a 7x5 character matrix. On the upper line, the grid numbering starts at 0 and progresses from left to right. The lower line behaves differently. Its numbering starts at 11, but progresses from right to left. Because of this arrangement, the text string must be reversed when writing to the first line. For the second line, no reversal is required. That is why, in the code, the function responsible for reversing the string is commented out whenever text is written to the lower line. For this demonstration, we did not spend time working with the predefined symbols available on the panel. Instead, they were simply left turned off. Since the display provides 2 lines of 7x5 character matrices, it becomes very easy to implement more advanced animations. For example, a Pac-Man style animation or even a Space Invaders style animation, similar to those we have already demonstrated on other single-line displays. So that is certainly an interesting idea for anyone looking to expand the project. As you might expect, the code used for this panel relies on a few external libraries. To simplify string handling, pointers were also used throughout the implementation. At first glance, this may seem a little intimidating, but with a bit of patience and experimentation, I am sure you will quickly understand how everything works. And once the basics are understood, this panel becomes a very enjoyable platform for creating custom animations and display projects.